All right, couple minutes after the hour, let's go ahead and jump into it. So, like I said, appreciate everyone joining in. Hope everyone's having a lovely Wednesday morning or afternoon, wherever you are. My name is Bijan Nyakon. I'm a technical account manager with Altair's aerospace and defense team. I guess now technically Siemens, so we'll be updating our presentations on here soon, our logos and everything like that. But yeah, today I'm going to talk to you guys about general model checking and validation within HyperMesh. So really just the tools within the validation ribbon of the interface, if you've seen that. So, I'll go through and kind of touch on some of the more like basic approaches for how you can check things like mesh connectivity and equivalencing nodes, like enforcing mesh connectivity wherever you lose it. So we'll take a look at that a little bit. We'll also just take a brief look at checking mesh quality, since that can also sometimes be an important factor in getting a good runnable model. Not too much time, since we've touched on a lot of mesh editing and mesh quality editing topics in the past. But we'll touch on that briefly, and I really want to spend some time also on the model checker within HyperMesh. So this is a pretty good tool for really just checking for any types of really wide range of checks that or issues with your model that might result in an error or potential error whenever you try to run it with whatever solver you're using. So we'll take a look at that and how you can create custom checks, which can be helpful as well. So. And if we have some time at the end of the session, I'll touch just briefly on like penetration checks and mass reports and things like that. All right, so let's go ahead and jump into it now that I've done my yapping. Okay, so I'm going to do this in our latest and greatest 25.1. HyperMesh 26.0 should be coming out pretty soon here. And we'll, once we get that full release, we'll start doing the demos in that version. Okay. So yeah, let me first load up some model here. And like I said, I want to first talk about mesh connectivity. Okay. And yeah, there's a few different avenues of mesh connectivity that I like to discuss. So one would be, for example, 2D mesh connectivity. So let's take a look at that. I got this component here that already has a shell mesh on it. So I'm going to go ahead and right click and isolate that component here. So let's say, for instance, I had some disconnect in my elements that I didn't know was there. So I'm just going to create that artificially here. So I'm going to use the detach tool. If you guys aren't aware of this, this just lets you, detach elements from other elements. So I'll grab some box of elements here, detach. So right off the bat, you can kind of see that edge. So generally, HyperMesh will give you some hints, just like right off the bat, like right in your face, that you might have mesh connectivity issues. So I personally wouldn't recommend just using this little edge here as a foolproof method for checking that mesh connectivity. So for 2D meshes, what I would recommend is we'll go to the validate ribbon. I recommend using edges. In my opinion, edges works better for highlighting any sort of free edges in a shell mesh, whereas faces are typically better for like highlighting any sort of interfaces between 3D elements, for example. So I'll show that as well, but at least for the context of a shell mesh here, so like I got that um, disconnected portion of the mesh that I artificially created. So if I come into the edges, select all my elements, I'll just do Control A, select all my displayed elements, and then I'll do review. So, right, this is why I personally recommend using the edges tool. It makes it very clear, very explicit where you have any sort of free edges or disconnects in your mesh here. So I can tell pretty obviously, all right, cool. So I got a disconnect in my mesh right here. And then if you want, you could also hit the little play button to say find, or excuse me, yeah, find edges and create 1Ds. So you could also use this to create 1D elements that you can convert into beams, like around shell elements. So this has multiple uses, but at least in the context of this demo, the benefit is seeing any of those disconnects in your mesh. Okay, so and then once you sort of highlight or find those disconnects, you can then look in on it and then use the equivalence tool to reconnect those elements at their coincident nodes. So if we go into elements, or excuse me, equivalence, grab those elements, basically it'll search for nodes within this tolerance you set, so that if it finds more than one node that are, like, say, less than 0.01 units away from each other, then it'll equivalence them and connect the elements at those node points. So you can do a review, which I typically recommend before equivalencing. So if you do review, it'll give you a little line, so it tells you what nodes it's equivalencing. So you hit equivalence down here or up here, doesn't matter, or middle click on your scroll, your mouse button. That also works. And then yeah, and now we've connected our mesh there. So if you'd like, you can go back to edges, Control A, review, and now we no longer have that edge in there. Okay. So yeah, that's quick way method for checking shell mesh connectivity. You can also do the same thing for, or similar process for 3D meshes. Let me highlight my solids here. I'm going to come down here to solids and say right click show. And let me isolate. Oops, I'm going to go solids, select that solid, and isolate that solid. So I'm going to just generate a hex mesh right here. If you guys didn't know this, we have this thin solids hex meshing tool that allows you to easily and automatically hex mesh like a kind of thin bracket geometry like this. So I'm just going to say, maybe I want 2 layers through the thickness. We'll go ahead and mesh that. So yeah, I want to show, and I'll disconnect this as well. But checking and ensuring 3D mesh connectivity is very important for hex meshing, as a lot of the manual hex meshing, like hex dragging, it won't necessarily automatically equivalence the nodes at the common interfaces that you're dragging. So let me go ahead and detach. Oops, I want to detach elements. So yeah, like let's say, you did some hex meshing, you have some disconnects. Let me hide the geometry. Turn that off. So again, similar to with the shells, right? You can kind of see an edge whenever, just in general, and especially when you kind of highlight your elements or your part. But for a more, at least for 3D, checking 3D mesh connectivity, you can use the faces in a similar way to which in which I used edges, but it's, in my opinion, it's not as immediately intuitive because you would have to do a section cut to see those interfaces here. So like, to show you just what I mean, if I do faces, grab all my elements, and do play. So see what that does is it places these like face elements all on the boundaries of my 3D mesh, but it doesn't like necessarily tell me explicitly that I have a face in here, unless I do some sort of a section cut or hiding of my elements. So like, uh, let me just show the faces. So I'm going to right click on faces, say isolate. So where this really can be useful is then if you do a section cut, you can see, like, let me drag this down, get out of the way here. So doing a section cut, I can see that face there, splitting, like cutting across where I had that disconnect in my mesh. So this way does give you an explicit, tells you explicitly where and how your mesh is disconnected. But it just takes a little bit of an extra step to do a section cut, or just hide the elements would also work. But in my opinion, let me delete this and let me go elements, hit A for show all, and here we go. Let's get back here. So yeah, in my opinion, what I think is more helpful, and let me isolate this component one more time here, is using the equivalence for checking any mesh disconnection for 3D elements. So this works right same way as the equivalents for shell elements. You select your elements and you can review wherever you have any disconnects. So in my opinion, this is the best way to check mesh connectivity here for 3D for 3D elements. But just know that it is again going to be based on this tolerance you set. So if your tolerance is not high enough, it might not capture coincident nodes if there's a little bit of an offset between the coincident nodes. In this case, it wouldn't be an issue since I just disconnected those manually, but just want to give you guys a heads up on that. So yeah, just some tips there for checking mesh connectivity, and then again, I can go ahead and equivalence. All right. So I also wanted to, well, I guess while I'm still here, I'll just briefly mention element quality checks. So let me just display all my elements. I'm going to go elements, and if you hit A, it'll show all your elements. So yeah, there was I believe in the classic interface, we had an explicit panel for checking mesh quality, but in this version now it's just a face view. So if you come down to the visualization toolbar down here, you can just turn your face color off of automatic and just turn on element quality. Okay, and so yeah, this will give you based on whatever element criteria that you can specify, or if you just want to use the defaults. Yeah, this will tell you wherever you have like any sort of problematic elements. So like maybe if I did some craziness to this mesh here, it'll highlight it a little bit better. Let me move around. Yeah, so here you can see it updating real time. So yeah, if I create some crazy wacky elements there, now it's telling me, okay, it looks like this element is failing from the max quad angle over 140, and it looks like it's at 170. Yeah. So using the mesh quality view and using the element selector, you can just hover your cursor over each element that fails the check. You can see how it's failing, whatever check it's failing. And then for shell elements, you can use auto quality to fix it. Easy peasy. And then for 3D elements, you can use solid mesh optimization. So if you come 3D, this little edit dropdown, you can use the solid mesh optimization tool to fix those. So my colleague Christian showed this a few weeks ago. If you guys want more details on this, just check out our TET meshing demo on our YouTube channel that we uploaded a few weeks back. Okay, so that covers mesh connectivity and element quality. I also want to show model checks. So let me bring up a version of this model that's already meshed here. Okay. I'm going to drag and drop this solver deck for OptiStruct, and we'll load that in. Okay. All right, so in HyperMesh, if we go validate and select this little manage checks, this will bring up our model checker browser. Okay, and so by default, HyperMesh will have these preset model checks specific for whatever solver you're using. So I'm using the OptiStruct solver. So this is basically our Nastran like solver. If you don't remember how to set that, that's under File, Solver Interface. So as you adjust or change whatever active interface you have for your HyperMesh session, it'll change which options for model checks that it gives you so that it's giving you specific checks for that solver, right? So if you expand these folders, you can look at some of the checks it gives, checking for duplicate elements. And some of these, if you look at them, will have certain corrections to them, like delete duplicate 1D elements. So if it finds, in cases like this, if it finds duplicate 1D or 2D elements, you can just right-click, autocorrect, and delete those elements. So I don't think we have any here, but we'll run the checker just to see kind of what we're missing at least, what potential issues we might have with this model. All right, so we'll run checks. And let's see, so typically it would do this automatically. I must have changed something so it didn't, but if you right click, you can say show only failed checks or show only active checks. Let's say show only failed checks. we pass all of our checks? Oh, I don't think I only ran. Okay. I had the 1D elements selected when I hit run, so it only ran that single check. My apologies. Let me make sure I don't do that again. Let me just right click. You can also just right click in the empty space and say run. All right, there we go. So yeah, like I said, typically it'll just show you once you run, it'll show you the failed or like potential failing checks. So it gives me some things, properties with a missing material. So some of these are elements with a missing property. These would, of course, under the arrow or error folder, these would be checks or potential issues that would prevent your solver from running the model, right? So yeah, issues that could lead to critical errors in the solver. As opposed to the warnings that might just be, potential issues. Hey, are you aware that you're not using some of these materials or some of these properties? Okay. And so I don't think any of these would have automatic corrections. Yeah, it doesn't look like it. But what you can do is you can investigate these checks. So for example, for the property it's missing a material, I think you can just expand it and it'll show the property right here. But you can also, what you can do is right click, show in browser, and then review the property without a material in this browser here. So then I can just go and assign some material, maybe my aluminum. And now I can go back and run that check one more time. So you can rerun individual checks like here if I'd like. And now I see, blam, I get this little friendly check mark denoting now it's passing that check. So again, you have all of these as preset checks for each solver. We typically take into account requests from users to add more checks if there's anything that you think we're missing for a particular solver. So we're always open to that. But again, like I kind of teased at the beginning of the session, you can create custom checks using scripts. So let's take a look at that. Let me clear my results here just to simplify things. I'm going to right click. There's a lot of options here. Hopefully I'll make it more clear. We'll clear results, right click, show all checks, and then right click again, collapse all. Oh, okay. So let's go ahead and create a custom check. So I'm going to create my own custom folder just so that it's easy for me to manage my custom checks. But you can just like create a custom check into any of these existing folders. Just right click, create check. But I'm going to create my own custom folder. So I'm going to right click, create folder. All this, if I can type, custom model. Yeah, checks. There we go. And then I can right click again and create the check under that folder. So the check I'm going to look at, or really the issue that I want to address here, is that sometimes some of our customers, I should say, would have sometimes issues where old like legacy solver decks would maybe rewrite certain cards or corrupt certain cards so that it would create some scenarios like this one, for example, where you might have a C bush or a number of C bushes that are sharing or calling to the same node ID for GA and GB, which of course, would lead to an error. But HyperMesh wouldn't allow the user to create any of these like C bushes this way, calling to the same node for each GA, GB. However, importing the solver deck like this would still bring in the C bush into HyperMesh and then would lead to an error. So what we did was we created this script that we'll use to check for basically any C bushes that are sharing those or using the same node ID for each of those nodes. So without going through line by line, basically what we're doing is defining a procedure. So this is going to be the specific check, right? So you could have one script with maybe 5 procedures for 5 different checks, So in this case, we're just using one script, one check, and we're going to check for duplicate nodes on C bushes. Okay, so we're basically just calling to C bush elements, spraying C bush elements, and then we're saying, okay, if GA, so node 1 is the same ID as GA or node 2, then we're going to say that that is a failing element, okay? And if any of those failing elements exist, or excuse me, if any of those failing elements do not exist, we're going to say, all right, the model checker will say run and no failed entities found. But if this is not true, if there are failed elements, then HyperMesh, the model checker status will say run and found failed entities, okay? And then if that's the case, any of those failed elements will get stored into the model checker results that you can verify the same way we did by saying show in browser with the properties that had no materials, right? So it's basically just defining the process for the HyperMesh model checker for what to find, and then for, basically elevating those, or not elevating, exposing, that's the word, exposing those failed elements to you so that you can go in and then delete them or adjust them or do whatever you need to do. And so I got this version of this model has some of these C bushes that I put in here deliberately that share some of these, node A, node B are calling to the same node ID. So we should be able to pick up these C bushes with this model check. So let's go ahead and define it in our model checker in HyperMesh. So I'm going to say model check, and we're going to be checking for duplicate C bush nodes or node ID. Node IDs. Okay. So coming down here, our configuration is going to be a TCL check. So that's going to be the script that we're using. And we're going to want to specify what we're checking. So we're going to be checking elements. And so this way, by specifying this check entity, this will allow us to then go through HyperMesh to specifically look at which elements, which C bushes failed this check, right? And then we could say what kind of issue this would be, whether this would just be an actual error or maybe just something to warn the user about, or just some general info. So this is really just user preference. How elevated do you want this particular check to be? Okay, and then the TCL file, we'll call it to that script. So let me go ahead and just copy the file path. And then open up folder here, paste the file path, and then I'll call to that script that I just showed you guys. Okay. And then the function name, this is where you would call to the procedure that you've defined in the model check. So if we bring that up again, bring up our model check script. So that was this HM model check. So this is our procedure. This is what we'll copy in that function name. So if you had multiple procedures in one script, you would just follow the same process, but copy and paste this procedure name into the subsequent function names for the subsequent checks. Okay. And we should be good to go. Everything defined as is. So we'll go ahead and now deselect everything, right click, run. And yeah, there we go. You see we failed that check. It's telling us 4 elements failed that check. So now, because we specified check entities, now because of that, we can right click and show in browser. And now we can see those specific elements. So I can highlight them, right click, review to see where they are in my broader model. So yeah, it looks like they were just attached to these corner nodes. And then from there, I can then go into each of those. Let me turn off review here. So yeah, from there, I can then go into each of these elements and just redefine the GA and GB, or just go in and delete them. So up to you how you want to manage how you treat the entities that failed any check. Yeah, and now looks like we're passing that check. And HyperMesh will save these checks that you've defined in between models that you open. So if I closed out this model, opened up a new one, it would save this check. However, if you restart HyperMesh or open up a new session, it would not remember this. So what you can do in those scenarios is save this as a configuration file, and then override the the default configuration file for the solver interface. So what you would do is just say save config file, and then define a path here. So you could say like, I'll try to do this quick here. Config. And then you could name this custom checks.xml. And so you could just like every time you open up a new session, you could do just right click, load file, and then call to that file you just saved. Or you can just override that file I just saved into this file, or override this file with the file I just saved. So this would be the more like kind of would just be automatic, would automatically have all your model checks every time you open up HyperMesh. So you could Control C, copy that file path, and then I can come over here, paste in that file path, and then basically just move the custom checks I created into this file and just override it, like rename it and everything. So that would require admin permission for your machine. So there's that one little hiccup, but if you don't have that admin access, you can still just create the custom XML and then just load it in whenever you open a new HyperMesh session. Okay. So I've gone right up to the end of our time here. I apologize, folks. I also briefly mentioned the mass and penetration checks. In my opinion, these are pretty intuitive, but these just give you options for, in this case, checking mass, in which you can decide how the breakdown of mass is shown to you. And then you can just right click. I just want to mention this, right click and export to a CSV. So very easy to get a sort of part by part mass overview and then export it to a CSV. And then, yeah, don't really have time to get into this, but the penetration tools is pretty helpful for seeing where you might have any potential gaps or penetrations between your components while taking into account things like shell thicknesses, right? So if you were like worried about intersections, I don't think I have them all assigned here, but like if you're worried about intersections between some of these shells, like maybe doesn't look like there's one there or there, but if you're worried about any sort of like intersections between these parts based on their thicknesses, you could use the intersection tool to check that. Okay, so yeah, sorry I've run up right to the end of our time here, folks. Does anyone have any questions about this demo, this topic that I can help out with?